We're going to learn about the derivatives of trig functions. We're going to start with two very basic rules. Since this is not an AP class, I'm not going to give you the theory behind why these two derivatives are what they are. That is determined graphically. But we are going to give you the rules for these two. So, the derivative of sine of x with respect to x, that's what the d over dx means. It's not a fraction. It represents, it's the notation for derivative. And the derivative of sine is simply cosine. And the derivative of cosine is negative sine. Now we're going to use these two derivatives to prove what the derivatives are for the other four trig functions. Now, just like any of the trig identities, all of the derivatives of the other four trig functions can be determined by the derivatives of sine and cosine. So, remembering back to pre-calculus, you learned that tangent x is equal to sine divided by cosine. So we're going to start with substituting sine x divided by cosine x. And because this is a quotient, we're going to have to use the quotient rule. So, you start with the bottom. So, the bottom times the derivative of the top. Now, the rule that you just learned is that the derivative of sine is cosine. And then you're going to have the top times the derivative of the bottom, which is negative sine. And you divide it all by the bottom squared. Okay, so we have cosine squared x plus sine squared x. That is a very common identity that we use. And that's 1 over cosine squared x, and that is equal to secant squared x. Therefore, our derivative of the tangent of x is equal to secant squared x. Now, cotangent is the reciprocal of tangent, which means since tangent is sine over cosine, cotangent is cosine over sine. We're going to go through the same process using the quotient rule. Derivative of the top. So we're going to start with the bottom, sine times the derivative of the top, which is negative sine x. And then we're going to subtract the top times the derivative of the bottom. And the more you use these, the better you're going to get. Here we have sine squared x, negative sine squared x actually, and then we have minus cosine squared x. Well, if we factor out a negative 1, that gives us a negative sine squared plus cosine squared, and that's just 1. So that means we have a negative 1 over sine x. Now we want to write this as a trig function. We don't want a fraction as our derivative. So therefore, our next rule is that cotangent's derivative is negative cosecant squared x. Now if you look back at the derivative of tangent, you're going to see that its derivative was also a form of secant. You'll also notice that all of the cofunctions, cosine, cotangent, they have negative derivatives. So it will be interesting to see what happens when we get to cosecant. Moving on to the derivative of secant. I went ahead and substituted 1 over cosine because it's equivalent and everything is based upon the derivatives of sine and cosine. So we're going to start with the bottom times the derivative of the top, and the derivative of 1 is 0. And then we have 1 times the derivative of cosine, which is negative sine. And we're going to divide that whole thing by cosine squared. That just gives us sine over cosine squared. Well, I want to break up cosine into two parts. So I'm going to have cosine, 1 over cosine, times sine over cosine. And reason I wanted to do that is that 1 over cosine and sine over cosine, they are equivalents to trig functions. And after we reduce this and simplify, we can see that the derivative of secant is secant tangent. And for the first time now we have a derivative rule where the function is in its own derivative. And let's see what happens when we go to cosecant. Okay, the sixth and final trig function, we substituted for cosecant its reciprocal 1 over sine, and we're going to do the quotient rule again. So we're going to start with the bottom, sine, times the derivative of the top, 0, and subtract 1 times the derivative of sine, which is cosine. And we're going to divide by sine squared. Okay, what this leaves us is a negative cosine x over sine squared. And just like we did with the secant, I want to break this up. So I'm going to start with negative 1 over sine times cosine over sine. And our sixth and final rule for derivatives of trig functions, the derivative of cosecant is negative cosecant cotangent. Now if you go back and take a look at this and make a list of your 6 derivative functions, you're going to find something interesting, and I'm going to put this on the next slide. Okay, in summary, we started out with the basic rules that the derivative of sine is cosine, and the derivative of cosine is negative sine. And then combined with trig identities and these 2 rules, we found the derivatives of the rest. And we found that the derivative of tangent is secant squared, and the derivative of cotangent is negative cosecant squared. And then we found that the derivative of secant is secant tangent, and cosecant was negative cosecant x cotangent. Now for classes that have to memorize all of these rules, it's very important to notice something. If you look at all of the cofunctions, cosine, cotangent, cosecant, all of their derivatives are negative. And I'm going to put my negatives back here. Now, if you take a look at our tangent functions, the cotangent and the tangent, they both have squares. And then take a look at the secant and cosecant. They are both in their own derivatives. And it's noticing patterns like that that will help you learn these.